afternoon. We see about instructions. There are total so there are total 74 uh, instructions available in instruction set. There are total 74 instructions available in instruction set. This instruction set is basically given by manufacturers, right? So manufacturers are Intel for this 8080 chip. So 74 instructions are given by this manufacturer. Total, this 8085 basically works on those 74 instructions. So those 74 instructions are basically, or you can say there are so many patterns available for a single instruction. So total 246, or near about 250 patterns available, right? For those, or you can say flavors, right? 46 flavors available for those 74 instructions. Right? So this is basically idea about this instruction set. Now from that, first is data transfer instruction. Right. So first group is data transfer. Hmm. Right. Move RD, RS. So basically, this instruction is used to copy data from source register to destination register, right? So this is basically a data transfer instruction or used for movement of data, wherein this data is basically moved from one register to another register, right? Again, this is basically 1 byte instruction, right? Size of this is 1 byte. So example for this is move A comma B, wherein B is 8-bit register, data of 8-bit register from B to accumulator, right? So this is example you can see for given instruction. One more flavor available with move is move M comma RS, right? So this RS is register or source register. From that source register, data is basically transferred to memory, right? So it is transferred to memory, but address for this or address for memory in case of 8085 is basically loaded in HL register. So as and when your program refers this type of letter, a mnemonic, or you can say M, in that case, this is basically memory, and you will get the address of the memory in HL register. Otherwise, or you can say other way around, if you want to use this letter, you need to store the address where actually data is present into HL register, right? So if my memory is on 3000 address, that case, if my data is stored in 3000, 3001, that case, if I want to refer a memory, then this could be a memory. So address for this memory region should be loaded into HL register first, right? So if you want to work with memory in case of any program, and if you want to work rather use this later, then in that case, you need to store whatever data you have into memory, right? And the address of that memory should be loaded into HL register. So you need not to mention HL explicitly here. If you can mention memory or M over there, then it will take address from HL register itself, right? So this is about, data transferred from register to memory. One more is from memory to register, right? Next instruction is move the data from memory to register, or move into B from memory, or move into accumulator from memory. This could be the example, you can say, for data transfer, or you can say movement, right? So basically, uh, this thing, or you can say this type of instructions are basically used to transfer the data from either register to register, or register to memory, or memory to register. In this case, data is not going to alter from source region. If I say this is my source, in that case, data is not altered from source region, whereas data is basically altered from destination. Impact, you can say, right, of instruction is basically identified as destination, or you can say destination, whether it could be a register or memory, right? So this is how this move instruction works. Next is MVI RD, comma, data, MVI, right? So this instruction is basically for 8-bit data. Then this is, right, move immediately, right? Move immediately from where? From source to destination. Since data is present over there in instruction itself, that immediate data should be transferred into register. So example for this is move a comma 20 hex, or you can say move immediately to memory is 50 hex, whereas memory M is pointed by HL, right? Memory M is pointed by HL. So this is how you can immediately move the data which is present in instruction to either register or पुस्तक बंद कर. तसं कॉन्सन्ट्रेशन नाही होत. बाहेर संध्याकाळी किंवा नंतर माझं लेक्चर झाल्यानंतर परत वाच, लक्षात येईल. नाही तर कॉन्सन्ट्रेशन नाही. आणि मला माझ्यावर कॉन्फिडन्स आहे, तू त्यामुळे टेन्शन नको घेऊ. अदरवाईज मी सांगितलं असतं की ही गोष्ट मला नाही. सो दिस इज व्हॉट load. Hmm? Load accumulator, right? Load accumulator with content present at this address, right? So load accumulator from 5000 hex, right? That means whatever data is there at 5000 hex need to be copied into accumulator, which is of 8 bit. So movement of data is 8 bit itself, but address is given over there in instruction. So this is load accumulator with content from this address, right? So this is ADA 5000. Next is DLDM. This is the software or example for this is right. So what is there which is mentioned here? Load accumulator. You will find address of 16 bit in register pair mentioned in instruction. So if I say it's 16 bit or it's pair of register, then will only find B over there. So you need to identify address from those registers, right? You'll get higher order over here and lower order over next register, right? So in this case, you get the address of actually contents where contents are present in register pair. You need to load your accumulator with address which is present in register pair mentioned in instruction, and that is PC register pair, right? So हा जो ऍड्रेस आहे पॉसिबली हा 2000 आहे. तो इथं तुम्हाला ऍड्रेस मिळणार 2000. Take that address, find out your content which are present in 2000 location, and just copy whatever is there in that location to accumulator. This is basically what LDA is. Okay, now see, this is the instruction, or you can say syntax for instruction. Now, it will tell you the exact instruction. तर मी ऍड्रेस म्हटलंय, फक्त चेंज करतो with data, right? So हा ऍड्रेस मी इथं ऍक्च्युली तो ऍड्रेसच आहे, but you need to treat this as data. Why? Because you are not going to consider content from this address, but you are actually loading this address into register pair simply, right? So load data which is immediately present. मी हे चेंज केलं, right? Load the data which is immediately present in instruction into register pair mentioned in instruction, right? Load immediate data which is present in instruction into register pair which is mentioned over there in instruction. So what could be the output after this is your HL register is loaded with this data simply, right? So this is how LXI works, right? see, and store data is simply this, right? So what this instruction will do, load, hmm? Load HL pair, load HL pair with those content, right? But your memory locations are of 8-bit only, right? So you want to store, you want to load HL pair, which is of 16-bit. L is of 8-bit and H register is of 8-bit, right? So whatever address mentioned in instruction, just move to that address, find out whatever contents are present over there and load it in L register. Increment the memory location. Whatever contents you will find over there in memory, copy that instruction, sorry, data into yes register, right? So whatever address which is mentioned in instruction, that or content from that address needs to load into HL pair. First, you need to load register L and the content which are there at this address, which is mentioned in instruction, need to be loaded here in L register, and you need to increment that memory location. Whatever is there at next memory location need to load it into H register, right? This is basically LHLD, right? Next instruction is STA 16-bit address. Now just guess on this instruction. What could be the meaning for this? Exactly. This is storing accumulator with content present at this address, right? So if I write here 1001 X, then whatever is there at this location, right, in 2001 is copied into, stored into accumulate, and that is 50, right? So this is yes. Okay. Next instruction is, tell me about this instruction. STAS. If you are listening to me, no, just put it in chat. What is the meaning? Talking to, just find out the meaning of this instruction and put it in chat. मगाशी चुकीचं सांगितलं का काहीतरी? हा, स्टोअर अक्युमुलेटर आहे. हे मगाशी मी उलट सांगितलं. लोड अक्युमुलेटर नाहीये, स्टोअर अक्युमुलेटर आहे. तो स्टोअर दी कंटेंट ऑफ listen carefully. So this instruction is, you know, store the content of accumulator to this address. Right. So whatever is mentioned over there, or whatever data is, sorry, accumulator to store into specified memory location. Sorry, actually लोड असेल तर ते अक्युमुलेटर आणि रजिस्टर कडे जातात आणि स्टोअर असेल तर त्या केसमध्ये प्रोसेसर कडनं मेमरी कडे जातात. राईट, हे बेसिक डिफरन्स लक्षात घ्या. हे आता इथं माझ्या लक्षात. तर काय करतो आपण, स्टोअर अक्युमुलेटर, स्टोअर अक्युमुलेटर ऍड्रेस कुठे आहे त्याचा, रजिस्टर पेअर. So address is there in the register pair. Right. So whatever content of accumulator, you need to store those content into specified memory location. So the address of that memory location is to register these. Last time पण मी बहुतेक use केलं. Okay, SHID 16-bit address. Online, online skill. Just tell me what is SHID. In case of LHID, case of SHID, store the content of L register. Right? Content of L register at this address and content of at next address. Right? So the content of register L are stored into memory specified by 16-bit address. The content of H register are stored into the next. So basically, in this case, content of HL is not altered, but in LHLD, content of HL is altered. Then you identify the construction, right? SSLD and of HL. Next instruction is XP. Exchange. Exchange in HL and D, right? Exchange in HL and D. H contained with D, L contained with D, right? So content of HL register is exchanged with D. is S is that store the address of HL, whatever the contents of HL into that point. Right? Instruction loads the content of stack pointer register. The content quite high order, or this is high order address, low order address. So whatever the content, those are basically address, right? So low order address and high order address store it into or load it into stack pointer. Yes. CHL. XCHL. Exchange. Stack top with those concepts. So that the SP pointed to this solution. So the content from L to SP, then increment SP, increment SP, and load the content of H into to exchange the content with this. Right? So आता ते exchange आहे म्हणजे काय होणार? Yes. They contain इथं जाणार. They contain इथं जाणार. Right? तसंच इथले कंटेंट इकडं the exchange. Right? So whatever value is the stack top and its next memory location is basically changed with HL. Right? The next kind of register pair. Where to push? Back. Push the content from that. This is the case then. This is basically register pair. So content from lower register is pushed onto stack top, decrement that register, decrement, find out that. Okay, increment sorry, decrement and then higher order, right? That you need to track, right? If I exactly reverse process of push, right? You need to extract those content, right? Pop out those content from stack location in the reverse order. What is the content of pointed out by stack pointer, copied into lower register first, and then stack pointer is implemented by one and content of higher order, right? And last two instructions are in and right. So this is for peripherals. Those peripherals which are connected with your microphone, right? So in case of out, whatever content, right? If you are working with other devices or other peripherals connected to microphone, keep in mind that all those devices first deal with accumulator. Right? So whatever is the content is out, right? Or those contents are moved to peripheral. Case of case of in peripheral sends the data to microprocessor, but it is basically to accumulator. Which came from peripheral. Of input port designed by Cochran is basically all about data transfer. Uh, SPHL, PHL, push, pop, all, and so total 16 instructions are there in data transfer. Any query related to 16, put it in chat. Have any query of recording